Snowflakes may look delicate and artistic, but each one begins with a simple scientific trigger, a tiny speck floating high in the atmosphere. Here's how a snowflake grows from dust into a complex crystal. Every snowflake starts when a microscopic particle meets supercooled water vapor. These particles can be dust, pollen, salt, or even volcanic ash. Supercooled vapor clings to the particle instantly, forming a thin layer of ice. This moment is called nucleation, the birth of a snowflake. Once ice forms, the surrounding air begins depositing more water molecules onto that tiny crystal. These molecules arrange themselves in a hexagonal pattern. The hexagon shape isn't random. It comes from the way water molecules bond at the atomic level, forming natural six-sided symmetry. As the crystal grows, it develops 6 arms, because each corner of the hexagon collects vapor slightly faster than the flat sides. The crystal's journey downward is never steady. It moves through pockets of air with different humidity and temperature, and each change affects how the snowflake grows. Colder layers encourage sharper, needle-like branches, while slightly warmer layers create broader, plate-like shapes. Higher humidity creates more elaborate branching, because there is more vapor available to attach at the tips. Lower humidity produces simpler shapes with fewer extensions, often forming compact hexagons. The arms of a single snowflake grow in near-perfect sync because each arm experiences nearly the same conditions at the same time. But no two snowflakes match, because no two crystals follow the exact same path through the atmosphere. Even small differences produce entirely unique structures. As the crystal becomes heavier, it begins to fall faster. This changes how vapor attaches, altering its final shape. Some crystals collide and stick together, forming snowflakes made of several fused pieces, especially in calm wind conditions. In turbulent air, crystals may break apart, creating fragments that continue growing independently. By the time a snowflake reaches the ground, it may have passed through dozens of microenvironments, each adding a new layer of detail. The result is a tiny frozen record of the atmosphere's conditions, captured in a single, symmetrical design. So every snowflake isn't just beautiful, it's a scientific diary written one molecule at a time. If you enjoy cinematic explainers like this, stay curious and explore more with us.